This is the fourth and final type of Riemann sum that we're going to do, and that's the trapezoidal Riemann sum. So in the first three, we used rectangles with left, right, and midpoint. But this time we're going to use trapezoidal. And I drew a couple trapezoids up here just to remind you what trapezoids look like. But most of the time ours are actually going to look a little bit more like this, kind of up on their side. So if you look, if I draw a trapezoid here, that's more what we get. So I'll come back to that graph in just a minute, but I want to talk to you about the area equation for a trapezoid. This is the more traditional form, 1/2 times base 1 plus base 2 times the height, or they may say 1/2 times the height times base 1 plus base 2, but that's the same thing. But since we're doing them on their side, basically, it's going to be more helpful for us to word it as this second one. So this is the one we're going to focus on. The area is 1/2 times the base times height 1 plus height 2. Because here's our base, this would be height 1 and height 2. Now I want to make sure you understand what this equation is doing, because I think that'll make it easier to remember. What's really happening is you're adding up the heights and then dividing by 2, same as multiplying by 1/2, which is finding the average of the two heights. So if you look at this height and then find an average, it's basically taking the average, because that rectangle that I just drew would have the exact same area as the trapezoid. So by averaging the heights, you're basically creating a rectangle with the same area as that trapezoid. So that's what's happening. So as we try to do this very first one, this is our tried and true negative x squared plus 5 that we've used before. And as we come to the first subinterval, instead of picking the left endpoint or picking the right endpoint or even picking the midpoint, we use both the left endpoint and the right endpoint and then draw a trapezoid. So let's look at how we could write this. First of all, this 1/2 is going to be used for all of them. So instead of writing it over and over, let's just put a 1/2 out front. For this particular problem, the base is going to be the same for all of them. The base is again 2/5, so I'm going to put that out front. Now I need to put in my height 1 plus my height 2. So when I plug 0 in my equation, remember this is 0, so if I plug 0 in right here, I get 5. Plus, if I plug 2/5 in, I get 4.84. Now you don't need that extra parentheses, but I'm just trying to make it clear that that is our first trapezoid. So that's our height 1 and our height 2 from our first trapezoid. Now as we go to the second subinterval, we use the height at 2/5. Use a different color. We use the height at 2/5 and at 4/5 and draw a trapezoid. So the height at 2/5 is 4.84. The height at 4/5 is 4.36. And then as we go to the third subinterval, we use 4/5, the height there, and 6/5, the height there, and we draw a trapezoid. So that's going to give us 4.36 plus 3.56. And then we use the fourth one, height at 6/5, height at 8/5, so that's 3.56 plus 2.44. And then finally the last one, we use the height at 8/5 and the height at 2 and connect those for a trapezoid. So that's going to give us 2.44 plus 1. So I know that looks really long and terrible, but there's a way to shorten this even a little bit more for ourselves. If you notice, most of the heights get used twice. 4.84, 4.36, 3.56, and the 2.44. So instead of writing those twice, here's one way I would recommend you write it. So we still have to put our 1/2 out front, because that's part of the equation for a trapezoid. We put the 2/5 out front because that's our base. That's the same for all of them. And then my initial endpoint, my left endpoint, just gets used one time. But 4.84 gets used twice. And 4.36 gets used twice. And 3.56 gets used twice, and 2.44 gets used twice, and then my right endpoint, 2, just gets used once, so that had a height of 1. So if you notice, the first endpoint and the last endpoint just get used one time, but everything in the middle gets used twice. And as it turns out, let me go ahead and find this answer, and then I'll explain that. So we do 1/2 times 2/5 times all that mess. You should get 7.28 if I've done mine correctly. It turns out the trapezoidal sum is the average of the left and right sum. The trapezoidal sum is just the average of the left and right sum. So trapezoidal is the same thing as the average of the left and right sum. In fact, if you would prefer to never do the trapezoid this way and to always just find the average of the left and right, you can. But I want to show you why that works out that way. If you go back to our number line here, the left endpoint would be used for the left Riemann sum. So would 2/5, 4/5, 6/5, and 8/5. And then for the right Riemann sum, we would use the right endpoint 2, 8/5, 6/5, 4/5, and 2/5. So if you look, our left endpoint and our right endpoint just got used once, but all the ones in the middle got used twice, and then we find their average by dividing by 2. So the trapezoidal sum turns out to be the same thing as the average of the left and the right. Now, if a question ever asks you to do all 4 Riemann sums, left, right, midpoint, and trapezoid, I absolutely wouldn't bother doing the trapezoid. I would just average my left and right answers. But if it's me, and this is just my preference, if they only ask for trapezoid, I think it's simpler to just go ahead and do trapezoid instead of doing left and right and averaging them. But that's your prerogative. So let's do one more with trapezoidal. So here we actually will use 0 in 1/2. And you may be wondering, well, that's not a trapezoid, that's a triangle. That's true, but the formula for trapezoid will still work. We'll just have a height of 0. So let's go ahead and do that. Remember, trapezoid, the area formula is 1/2 times the base, height 1 plus height 2. So we need to always put 1/2 out front just because that's part of trapezoid. And I need another 1/2 because that's my base. So again, the first 1/2 is just the 1/2 that's always there with trapezoid. The second 1/2 is because that is our base this time around. So we get height 1, which we plug 0 in there, so 0 squared, plus 2 times the second height, 1/2 squared, plus 2 times 1 squared, plus 2 times 3/2 squared, plus 2 squared. Because I use the first one and the last one just one time, and I use the middle 3 twice. And it's going to look something like this. And when you plug all that in, you should get 2.75. So for trapezoid, always put a 1/2 out front times the base, and then your first and last point get counted once, all your middle ones get counted twice.